In this video, we're going to talk about how to solve systems of nonlinear equations. And usually what happens with nonlinear equations is we solve using substitution or elimination. So let's look at this first system. We have x squared plus y squared is equal to 25. 3x squared minus 16y is equal to 0. And it helps to think about what does that graph look like. If we look at that first equation, we know that's the equation of a circle and it's centered at 0, 0, and it has a radius of 5. So that equation would look something like this. And we're just trying to get a rough sketch as to what this looks like. So there's equation 1. Equation 2, if we were to solve that equation for y, and let's go ahead and do that. We see that that is the equation of a quadratic, and it's going to open up. So it's going to look like that. So if we take that circle and we put that quadratic on top, we see that there are two intersection points. Our goal is to find that intersection. So let's do that. Now, if you notice, both of these equations have an x squared in it. We could take that second equation and we could do a substitution for x squared. And that's going to avoid us having to take a square root of any kind of expression. So let's solve equation 2 for x squared. So if we were to do that, we would have 3x squared is equal to 16y. And then if we divide by 3, we have 16 over 3 times y is equal to x squared. So now that we have a substitution for x squared, we can take this guy and substitute into that first equation for x squared. And that will give us an equation that's written just in terms of y. So we're going to sub into our first equation. Our first equation says x squared plus y squared is equal to 25. Our x squared is 16 over 3y. So we're making that substitution for that x squared. And now let's get rid of fractions by multiplying both sides of this equation by that least common denominator of 3. Don't forget, you have to multiply each term by 3. So we have that. So we have a quadratic. To solve a quadratic, we need to move everything to one side of the equation. And I'm going to write this in standard form. And to solve this quadratic, we really want to try to factor if we can. We could use the quadratic formula. I'm going to use that AC method that we talked about at the beginning of class. In this case, our A times C is 3 times negative 75, which is going to be negative 225. So remember, we want two numbers, that multiply together to give us negative 225, but that will add to give us a positive 16. So let's start brainstorming. We could have a 15 and a negative 15. Those multiply to give us a negative 225, but that does not add to give us the 16. We know it's divisible by 5, but any combination of 45 and negative 5 will not add to give us a 16. But if we look at 25 and 9, if we take a positive 25 and a negative 9, that adds to give us that positive 16 that we need, and multiplies to give us the negative 225. So now we're going to do our rewrite step, where we rewrite that middle term in terms of our 25 and our negative 9. So notice 25y minus 9y is the same thing as 16y. And now we're going to do that factor by grouping. If we group the first two terms together, we could pull out a y. And if we group those last two terms together, we could factor out a negative 3. And that gives us a 3y plus 25 in the parentheses. Remember, you have to factor something out so that you have the same thing in both of these terms in the parentheses. And now we can pull out that 3y plus 25. And the leftovers are the y minus 3. So we have factored. And now we're going to set each factor equal to 0. So we're going to get y equals 3 and y equals negative 25 over 3. So these are our possibilities. Now that we have y, we've got to figure out what x is going to be. So let's find x. Now, up here, we had taken that second equation and solved it for x squared. So let's use that equation now. X squared is equal to 16 over 3 times y. And let's make our substitutions. We have y equals negative 25 over 3. Check out what happens when we substitute that in. We have x squared is equal to 16 over 3 times negative 25 over 3. 16 times negative 25 is a negative 400. So we have negative 400 over 9. But if we were to take the square root, notice we can't take the square root of a negative and get a real number. So what that tells us is that there's no solution for this problem when y equals negative 25. So negative 25 is not even going to work for this problem. But let's see what happens when we substitute in 3. That negative 25 over 3 ended up being an extraneous solution to the problem. But if we substitute in 3, x squared is equal to 16 over 3 times 3, which is 16. And now if I take the square root of both sides, remember we chose to take the square root because we needed x. So we're going to have a positive and a negative value. And it's going to be positive and negative 4. So our points of intersection are going to be at when x is 4, y is 3. And when x is negative 4, y is 3. The y is 3 came from over here when we solved after factoring. The x's plus and minus 4 came from when we substituted the 3 in. And we could always check this. Let's go to our graph. We could go to GeoGebra. Type in the equation of the circle, x squared plus y squared is equal to 25. The equation of the quadratic, 3x squared minus 16y is equal to 0. Remember that rough sketch we did at the beginning of the problem? Here is a better picture of what's going on. So you can see there's 2 intersection points, one in the first quadrant, one in the second quadrant. And GeoGebra is kind of nice because if we were to mouse over and click on the intersection, it tells us the intersection is at 4, 3 and at negative 4, 3, which backs up what we got algebraically. Let's look at one more. This is where you may want to pause the video, try it, and then come back and check your answer. So if we look at this one, we have x squared minus y is equal to 0, and we have 2x plus y is equal to 0. So this guy is a quadratic. If we were to solve for y, it would be y equals x squared. This guy is the equation of a line with a negative slope. It's going to look something like that. We are looking for 2 intersection points. We could always graph this in GeoGebra or in the calculator to get a better idea of what that graph looks like. So with this one, notice we only have one squared term, so it's going to be easier to solve one of these equations either for x or for y. Since I've already solved that second equation for y, let's just go with it. So we said y is equal to negative 2x. We solved equation 2 for y. And now we're going to substitute that into equation 1. So we have x squared minus y, and our y is negative 2x is equal to 0. So that means x squared plus 2x is equal to 0. We can factor an x out. So we're going to get x is equal to 0 and x is equal to negative 2. And now that we know x, we need to find y. We have two scenarios, when x is equal to 0 and when x is equal to negative 2. And let's use this guy. So we know y is equal to negative 2x. If we substitute in 0, we're going to get y is equal to 0. So our point is the point 0, 0. If we substitute negative 2 in, we have y equals negative 2 times negative 2, that is 4. So our point is the point x equals negative 2 and y is equal to 4. We could always plug this into GeoGebra and we could verify that those are the solutions. I'll leave it to you to verify that, but those are definitely the solutions. It makes sense also based on our quick sketch of our graph. So that's how we solve systems of nonlinear equations.